Welcome back, Honors Algebra 2. Hopefully those quizzes went well. Today we're going to do the same thing, but now we have three variables. So we're now dealing with three different variables and three different equations. You need to have the same amount of equations as you do variables in order to do these problems. So you will be using both substitution and or elimination for these. Now the key to these three variable problems is to break it down and get it down to two equations and two variables first. So let's look at the first. I'm going to look at the first and the second. So I'm going to look at these two first. So for 1 and 2, I have 3x plus 2y minus z equals 10. And I'm going to choose to get rid of the x's just because. That's what I'm going to choose to do. So in order to do that, I multiply the second one by negative 3, and I will get negative 3x minus 12y minus 6z equals negative 9. Do not forget to multiply that in either. Okay, and now I can eliminate the x's by adding down. 2 minus 12 is a negative 10y. Negative 7z equals 1. So this is one of my two equations I got it down to. Now, in order for this to work, though, we now pick two of the other ones. You can either pick 1 and 3 or 2 and 3. I would say 2 and 3 is probably easier because the other thing we have to worry about is we have to eliminate the same variable. Okay, so if I pick 2 and 3, I need to still get rid of my my x variable, because then otherwise I can't do the next step, which is doing another linear combination between the y's and the z's. So for 2 and 3, I'm going to multiply this second one by negative 2 now. Okay, negative 2 times all of this is negative 2x minus 8y minus 4z equals negative 6. And then the other one is just 2x plus 3y minus 5z equals 23. Now I can do linear combination again, or elimination, whatever you want to call it. And you get negative 5y minus 9z equals 17. There is equation number 2. Now it's back to a problem that you guys were doing before the quiz. We have two variables, two equations. Now we can take each of those and do linear combination. The easiest way to go about this probably would be to get the y's to cancel next, because we can easily multiply this equation by negative 2 and change everything in there. So we're going to take both of these equations. So I have negative 10y minus 7z equals 1. I also have, now I'm going to multiply this equation, I'm going to do this down here, by negative 2 again. So this becomes positive 10y, this becomes positive 18z, and this becomes negative 34. Okay, again, this is very tedious. You have to be careful as you're working through this so you don't make a mistake. We get, these cancel, the z's are 11z is equal to negative 33, and z is equal to negative 3. Now, I believe for these, most of the time, if not all of the time, you will get nice numbers. So, just remember that for 3 variable, because I don't want to be grading things with crazy fractions and you guys by hand. So, alright, so you get z is equal to 3. Now you just work backwards. Go take this z and put it into one of these two equations that you had with y's and z's. So, I'm going to take this and say negative 10y. I'm taking this equation here now. Negative 10y minus 7 times negative 3 equals 1. Negative 10y, this becomes plus 21 equals 1. Negative 10y equals negative 20. And y equals positive 2. Alright, we're almost there. Go back to one of the first equations with an x in it. I'm going to pick the middle one just because the x is by itself. And finally, we do x plus 4 times 2 plus 2 times negative 3 equals negative 3. X plus 8 plus negative 6, I should probably just say minus 6 there, is equal to negative 3. This is basically a positive 2. So x is equal to 1. Oh, that is not a negative 3 though, is it? That is my bad. Let's just erase that real quickly. This is 3. I just wrote that down wrong from the equation. I was looking at what I was multiplying by. Alright, so x is equal to 1 when you subtract 2. And then our final solution set, guys, remember, put it in correct alphabetical order. Do not say negative 3, 2, 1. X is 1, y is 2, z is negative 3. This is my solution to this 3-variable, 3-equation system. Hope that is helpful. And let's go on to the next one. Now the next one we have here, the problem we have is that we're missing a letter in each one. But that doesn't matter. We can rewrite these so that there are letters in there. I'm going to say that this is 2x minus 3y plus 0z, just so I know what is there, equals 5. I have 0x plus 4y plus 2z equals negative 6. And I have 5x plus 0y plus 7z is equal to negative 15. So I look at this and I go, what can I eliminate? Well, first of all, if I look at the first two equations, I can eliminate the y's. That's actually the only thing I can really eliminate, because I can't get this 0 to turn into anything. I can't get that x to turn into anything. So in order to eliminate the y's, I need to get this to a common number. I would say that that would probably be 12. So to get that to a negative 12, I keep that as the negative. So I'll multiply this one by 4, and I'll multiply this equation by 3. And when I do that, I get 8x minus 12y plus 0z equals 20, and 0x plus 12y plus 6z is equal to negative 18. So I get 8x plus 6z is equal to 2. That's one equation. Now I want to use, here's the key now. I got this down to one equation with two variables. I have x and I have z. Do we have another equation where we have an x and a z? Yes, we do, right here. We don't have to do any more work now. We don't have to do another 2. We can use this equation and this equation to now do a 2-system, 2-variable system. Okay, so here we are. I'm going to eliminate the x's. So in order to do that, we have to get these to 40. I'll multiply this one by 5. And I'll multiply this one by negative 8. Okay? So now our new equations become 40x plus 30z equals 10, and negative 40x minus 56z is equal to 120. Now we can add down. We get negative 16, that's 26. I cannot subtract today. 26z is equal to positive 130. And when you divide by negative 26, you get z is equal to negative 5. Okay, so that's part 1. Now we just have to plug into the other equations to get our answers. So I'm going to take any one, you can take any one you want. So let's do the 4y and 2z equals negative 6. 4 times y plus 2 times negative 5 is equal to negative 6. 4y minus 10 is equal to negative 6. 4y is equal to positive 4 when you move that over. Y is equal to 1. Okay? And the last one. The last one we'll do, well, we can use either x or y. Actually, I'll just use the first one now. 2x minus 3y. And we know what y is now. 2x minus 3 equals 5. 2x equals 8, so x equals 4. Alright, so we got 4, 1, negative 5 is our final answer. And we are done with that one. Alright, this one here, when you first try to do this one, you'll see what happens, and I'm going to actually talk about this in class more, but let's start it and then see what happens. So I'm going to, again, eliminate a variable here. Really easy variable to eliminate are the z's. Add them together, and guess what? They're gone. So really, we don't have to actually do any math except for adding these things together. When you add these equations together, you get x plus y equals 3. Now I'm going to do these two, the second and the third, but in order to do that, I have to multiply the bottom by -1 to change all the signs. I can just do this up here. I'm going to make this a negative, this a positive, and this a positive, and this a negative. So when I add these together, I get 3 and a -5 is a -2x. -3 plus y is a -2y, and a -6. So now I'm down to these two. Well, now I just am going to multiply this top one by 2. Okay, so I'm going to get 2x plus 2y equals 6. Well, if you look at this and you add down now, you get 0 equals 0. Back in when we did 2 variable, that was infinitely many solutions on that line. So remember, infinitely many solutions on those lines. Okay. So here's what you do when you get these. Number 1. Well, first you have to find all the variables in terms of 1. In terms of one variable. You guys might be thinking, aren't we just done? Well, no, we want to know what those lines are. Like, we want to know what's going on here. So, here's what we do. In this case, what I'm going to do is I'm going to find y in terms of x, and then you substitute, and then we'll find z. So right away I go to this first equation, this green equation. I'm going to jump out here because I'm going to find everything in terms of x. So x is going to be my variable. Well, that means that when I solve for y, y is equal to 3 minus x. So I know now what y is equal to. So I have x, I have y equals 3 minus x, and now I can find what z is equal to in terms of x by plugging these values in. So I'm going to say negative 2x plus 4 times 3 minus x, because that's what y is, plus z equals 1. And I know this might be confusing, and we're going to talk about this tomorrow in class too, why we do this. But basically we're just trying to get a solution set in terms of one variable that will satisfy all three of these equations. Alright, combine our like terms, we get negative 6x plus 12 plus z equals 1. You get, move the 6x over, move the 12 over, you get z is equal to 6x minus 11. Okay, so now I can say that there's infinitely many solutions on, and they would follow these variables. If x is a certain number, then you would get the solution 3 minus x for the y and 6x minus 11 for the z. What this gives you, again, is for any value of x that you can pick. Let's say I want to know what y and z are when x is 3. Well, you can now sub it in and solve. So that's why we did that, just so we have that information. So this would be my answer, but it's technically infinitely many solutions on those lines. So, all right. So don't worry too much about this though, but it's just important to look at. This is more important. So let's do a word problem. I want you guys real quick to pause and see if you can set this up. Okay, you're going to need 3 equations, 3 variables. Kind of like the 2 equations, 2 variables, but there's always a random third equation now. Alright, so first thing I'm going to do is I'm going to say R is equal to regular, P is equal to premium, and E is equal to elite. I know it's very creative of me to come up with those letters. So they sold a total of 440 tickets, and the total revenue they got was $3,940. So first of all, total number of tickets, that's the first equation you always do. So we get R plus P plus E is equal to 440. The second equation you always do is the cost equation. Regular tickets cost $5 a piece, premium tickets cost $15 a piece, and elite tickets cost $25 a piece. And that equaled the $3,940. Now, this is the third one. The number of regular tickets was 3 times the number of premium and elite tickets combined. So, what that means is, I'm going to do that over here because I don't want that involved in my setup over here. The number of regular tickets was equal to 3 times the number of premium and elite tickets combined. That is what that is. So R is equal to 3P plus 3E. Okay? So I can come up with another equation now that involves my first equation and sub in for my R, actually, is what I can do. I know R is equal to 3P plus 3E, and I could plug that into both equations. So I know what R is equal to already. I don't even have to do elimination. This is a substitution one. Okay? So what happens is I get 3P plus 3E plus P plus E, and down here equals 440. Down here I get 5 times 3P plus 3E plus 15P plus 25E equals 3940. And when you multiply all that out and simplify, your equations are 4P plus 4E is equal to 440. And the other one is, you get 15P and another 15P is 30P. You get 15E and 25E is 40E. And you have the other equation. So if you have, so right here, the first two equations are here. The third equation, they give you R is equal to these two things. If you have a letter already equal to the other two variables, just sub it in. Do substitution, and that will get you down to 2 equations and 2 variables. So, for example, now I have this. I'm going to multiply the top one by -10, and I get -40P minus 40E is equal to, what is that? -4400. So I get -10P is equal to -460. And P is equal to 46. So I have P now. Now I could plug that back into this equation right here. You can pick any equation really that you have. 4 times 46 plus 4 times the elite equals 440. 4E is equal to 256 when you move that over, and E is equal to 64. And finally, we know that all 3 tickets add up to 440. So up here I'm going to do R plus 46 plus 64 is equal to the 440. So you get R is equal to 330 tickets. So how many of each type of tickets were sold? There was 330 regular tickets. There was 46 premium. And of course there were 64 elite. So that would be my final answer. Okay? Alright, so we will do another one of those in class, and I will see you guys tomorrow.